Welcome, my name is Adrian, and I will be your instructor for this course. This is a conceptual course, there is no coding involved. If you are not a developer, the objective is to provide you with a solid enough understanding of the topic so that you can exchange with and understand a data engineer. If you are interested in actually developing data engineering projects, the objective is to equip you with conceptual knowledge, allowing you to get the most out of our data engineering curriculum. The first chapter will clarify what data engineering is, specifically how it relates to big data and how a data engineer differs from a data scientist. Data engineers build data pipelines, so we will end this chapter by looking into these as well. Building on these foundations, in the second chapter, we will then take things in order. We will study data storage, the different types of data structures, the central role that the SQL language plays in data engineering, and some storage solutions. Once data is stored, it is ready to be processed. This will be the topic of the third chapter, where we will dive deeper into processing methods and tools, scheduling, parallel computing, and cloud computing. Throughout the course, we will look at how all these data engineering concepts are implemented at a fictional music streaming company named Spotflix. Let's take things from the start then. There are 4 general steps through which data flows within an organization. First, we collect and ingest data from web traffic, surveys, or media consumption, for example. Data is stored in raw formats. The next step is to prepare it, which includes cleaning data, for instance finding missing or duplicate values, and converting data into a more organized format. Once the data is clean and organized, it can be exploited. We explore it, visualize it, build dashboards to track changes, or compare 2 sets of data. Finally, once we have a good grasp of our data, we're ready to run experiments, like evaluate which article title gets the most hits, or to build predictive models, for example, to forecast stock prices. Data engineers are responsible for the first step of the process, ingesting collected data and storing it. They have a great responsibility, as they lay the groundwork for data analysts, data scientists, and machine learning engineers. If the data is scattered around, corrupted, and difficult to access, there's not much to prepare, explore, or experiment with. And that's exactly why you need a data engineer. Their job is to deliver the correct data, in the right form, to the right people, as efficiently as possible. They ingest data from different sources, optimize the databases for analysis, and manage data corruption. Data engineers develop, construct, test, and maintain architectures, such as databases and large-scale processing systems to process and handle massive amounts of data. If you're not sure what this all means, that's okay. The course will unpack all this jargon and explain the what, the why, and the how. With the advent of big data, the demand for data engineers has increased. Big data can be defined as data so large you have to think about how to deal with its size, because it's difficult to process it using traditional data management methods. This graph helps make sense of the growth of big data. In order of volume, big data is mainly composed of sensors and devices data, social media data, enterprise data, and VoIP data. Big data is commonly characterized by 5 V's: volume, the quantity of data points; variety, the type and nature of the data, text, image, video, audio; velocity, how fast the data is generated and processed; veracity, how trustworthy the sources are; and value, how actionable the data is. Data engineers need to take all of this into consideration. Alright, now you not only know what's waiting for you in this course, but also how data flows through an organization, when a data engineer intervenes, what their responsibilities are, and how they relate to big data. Let's check your understanding. Great job on these exercises! In the previous lesson, we got acquainted with how the data flows through an organization, focused on the data engineer's responsibilities, and quickly mentioned data scientists. To prevent the confusion and assumptions that come with buzzwords, let's clarify how data engineers and data scientists contrast and compare. You already know that data engineers focus on the first part of the workflow. Their role is to ingest and store the data so it's easily accessible and ready to be analyzed. Data scientists intervene on the rest of the workflow. They prepare the data according to their analysis needs, explore it, build insightful visualizations, and then run experiments or build predictive models. Data engineers lay the groundwork that makes data science activity possible. Let's see how data engineers enable data scientists. Vivian is a data engineer at Spotflix, our music streaming company, and Julian is a data scientist. Data engineers ingest and store collected data, so that data scientists can exploit it. Data engineers ensure that databases are optimized for analysis, correct table structure, information easy to retrieve, while data scientists access the databases to exploit the data it contains. At Spotflix, Vivian makes sure that Julian can easily access tracks, artists, listening sessions data, and can analyze it without too much preparation work. Data engineers build data pipelines. The next lesson is focused on this topic. Data scientists use the pipeline's outputs. At Spotflix, Vivian builds the pipeline that pulls listening sessions data so that Julian's analysis remain up to date. Based on the above, it's no surprise that data engineers are software experts, while the area of expertise of data scientists is analytics. In general, Vivian uses languages like software-oriented Python or Java and SQL to create, update, or transform databases, while Julian uses analytics-oriented Python or R and SQL to query, or in other words, request information from databases. Okay, now you understand at which stages data engineers and data scientists intervene and how data engineers enable data scientists. Time for a sanity check. Alright, we've mentioned the term pipeline several times by now, so let's focus on it for this lesson. You may have heard that data is the new oil, as first coined by The Economist, so let's follow this idea. We extract crude oil from an oil field. We move the crude oil to a distillation unit where we separate the oil into several products. Some products are sent directly to their final users. For example, some pipes go straight to airports to deliver kerosene. Other products, like gasoline, are sent to gas storage facilities and stored in big tanks before being distributed to gas stations. Other products, like naphtha, go through several chemical transformations to create synthetic polymers, for example. Manufacturers use synthetic polymers to create new products like CDs. As you can see, we have many pipelines tying it all together. CDs? So last century, Vivian thinks. However, to manage data for Spotflix, she follows a procedure similar to oil processing. Companies ingest data from many different sources, which need to be processed and stored in various ways. To handle that, we need data pipelines that efficiently automate the flow from one station to the next so that data scientists can use up-to-date, accurate, relevant data. This isn't a simple task, and that's why data engineers are so important. At Spotflix, we have sources from which we extract data. For example, the user's actions and listening history on the mobile Spotflix app, the desktop Spotflix app, and the Spotflix website itself. We also have websites Spotflix uses internally, like their HR management system for payroll and benefits. The data is ingested into Spotflix system, moving from their respective sources to our data lake. No fear, we will talk about data lakes in the next chapter. These are our first 3 pipelines. We then organize the data, moving it into databases. We will talk more about databases in chapter 2 as well. It could be artist data, like name, number of followers, and associated acts, albums data, like label, producer, year of release, tracks data, like name, length, featured artists, and number of listens, playlist data, like name, song it contains, and date of creation, customers data, like username, account opening date, subscription tier, or employees data, like name, salary, reporting manager, updated by human resources. These are 6 new pipelines. Some albums data can be extracted and stored directly. For example, album cover pictures all have the same format, so we can store them directly without having to crop them. One more pipeline. Employees could be split in different tables by department, for example sales, engineering, support, etc. We will talk about tables in chapter 2 as well. For now, 3 more pipelines. These tables could be further split by office, for example the US, Belgium, and the UK. If data scientists had to analyze employee data to investigate employee turnover, for example, this is the data they would use. 3 more pipelines. Tracks would need to be processed. First to check if the track is readable, then to check if the corresponding artist is in the artist database, to make sure the file is in the correct size and format, etc. That's one more pipeline that we will unpack in chapter 3 when we will talk about data processing. The data can then be stored in a new, clean tracks database. This is one of the databases data scientists could use to build a recommendation engine by analyzing songs for similarity, for example. And that's our last pipeline. Alright, that's a lot of pipelines. In a nutshell, data pipelines ensure the data flows efficiently through the organization. They automate extracting, transforming, combining, validating, and loading data to reduce human intervention and errors, and decrease the time it takes for data to flow through the organization. Don't worry, we'll cover this in detail in the last chapter. One term you will hear a lot is ETL. It's a popular framework for designing data pipelines. It breaks up the flow of data into 3 sequential steps. First, E for extracting the data, then T for transforming the data, and finally L for loading this transformed data to a new database. The key here is that data is processed before it's stored. In general, data pipelines move data from one system to another. They may follow ETL, but not all the time. For instance, the data may not be transformed, and routed directly to applications like visualization tools or Salesforce. Okay, now you understand what a data pipeline is, what it's used for, why it's important, how we use them at Spotflix, and where ETL fits in. Let's solidify your understanding of data pipelines with a couple exercises, and then onwards to chapter 2 to dive into the details of data storage.